Hi everyone, today we are discussing the greatest common factor of monomials and polynomials. We know that a greatest common factor is the largest whole number that divides evenly into each term, okay, or the other two numbers. But not only do we have to deal with our numbers, but we also have to look at variables, because this time we can have numbers and we can have variables. Okay, so we're going to do a couple of examples and explain. So in each one, we want to find the GCF, which is our greatest common factor. So we're given 2x plus 12. Okay, and in this 2x plus 12, the first thing we want to do is find the largest number that divides evenly into 2 and into 12. Well, 2 goes into itself, and 2 also goes into 12. In other words, if I take 12 and divide by 2, do I get a whole number, meaning a number with no decimals? Okay, and I do. So the largest number that will go into both 2 and 12 evenly, no decimals, is the number 2. Okay, then I look at variables. Well, 2x has 1x and 12 doesn't have any. So there are no variables that are common in both of those terms. That means that my greatest common factor is just 2. Okay. All right. So here in the second example, I made it a little harder. I have 12x cubed minus 16x squared. All right. So we want to find the largest number that can be divided evenly into 12 and 16. So you could try, does 2 work, 3 work, 4 work, 5, 6, 7, 8, and you could just keep going down the line and seeing the largest number that will divide evenly, okay? Or you can create what we call the factor table, okay? That's what this table over here is. 12 can be made up of 2 times 6, 3 times 4, okay? 16 can be made up of 2 times 8 and 4 times 4. So what's the largest number that they have in common in their factor table? And that, as you can see, we've pointed out, is the number 4. Okay, 12 can be divided by 4 evenly, and 16 can be divided by 4 evenly. So that is our greatest common factor for the numbers. Now we have to see what is the greatest common factor for the variables. Well, I have an x cubed and I have an x squared. So what is the most that each one contains? Well, they each contain 2. Okay, x squared contains 2, it has a power of 2, and 3 is more than 2, so it has at least 2. So that means our variables are x squared. So the entire GCF, if I put them together, are 4x squared. Okay, so we're going to work a few of these together and see what we come up with here. So we're going to try this first one, A, which is 3x plus 18. I need to find the largest number. Okay, so I need to find the largest number. So 3 is just 3. So is 18 divisible by 3? 18 divided by 3 is 6. Okay, so 3 is the largest number. And if you wanted, you could have made that factor table up here. Okay, you've got 3 and you've got 18. So this is 1 times 3. This is 2 times 9. Okay, whoops, sorry. 3 times 6. So right here, the largest number they have in common is 3. What is the largest number divisible by each number? Okay, and then there's no variables, the x and nothing. So my GCF here is just 3. Okay, so let's go to B. And this time we're dealing with 28 and we're dealing with 12. Okay, so I can go back to my factor table. Sorry, I'm writing a little bit crooked today. Here, let's erase that and do it again. Perhaps. Here we go. Okay, so let's try this again. Oh yes, much better. Okay, so I've got my factor table going on here, and I can have multiple rows if I need them. So I've got to break down 12 and I've got to break down 28. Okay, well, we've got 1 times 12, 2 times 6, 3 times 4. Okay, 28. Well, you could have 1 times 28, but we know it's not going to be 1 and 28. So let's do 2 times 14. Okay, 3 doesn't work evenly. 4 times, 7. Okay, 5 doesn't work, 6 doesn't work, and then we start repeating ourselves with 7. Okay, so here, the largest number that I see happens to be 4. Okay, so by number, we've got the 4, and then we have to do by variable. This has x squared, has 2 of them, and this has 1. So the most that I could take evenly would just be an x. So here my GCF is 4x. Okay. All right. In C, it's the same thing. We just now have another variable, another y. Okay, so I have a 10, a 4, and a 2. All right, well, the biggest number that it could be is 2. Okay, and that's because this is the smallest number I'm dealing with. So is 10 divisible by 2? Yes. And is 4 divisible by 2? Yes. So by number, I really don't have to do a tree or a table. I can just say it's 2 because 10 divided by 2 is a whole number and 4 divided by 2 is a whole number. All right, then by variables, we actually have 2 different variables. So with the x's, I have cubed, squared, and remember, if it doesn't have a power, it's just to the power of 1. So we can take 1x from everything. And then we also have y's. We have a y squared, a y, and a y squared. So the most that I could take from everybody evenly is just one of the y's. So my GCF is 2xy. Okay. All right, so over here on the last one, now this time we have a lot of numbers. We have 21, 6, 12, and 15. So I know 6 isn't going to work, right? So I might want to do a table, or I could try different factors of 6. So let's see what we've got. We're just going to create a little table here. So we have 21, 6, 12, and 15. So we're just going to create us a table and see what we come up with. So 21, 2 doesn't work, but 7 does. 3 times 7. That's really all you've got for 21. 6 is just 2 times 3. 12, whoops, 2 times 6 and 3 times 4. 15 is really just 3 times 5. Okay, so what's the largest number that I see that's in every one of these? And I see a 3 here, 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 and here. So that means that 3 is the number portion. Okay, every one of these is divisible by 3. And you probably could have done that one in your head. Okay, variables. I have x cubed, x squared, an x, and nothing. 15 doesn't have an x. So there is no variables that I can use. So my GCF is only 3 here. Okay, so remember, you're pulling out the most that they all share. Okay. All right. Now, the next step, once we find that GCF, is we want to factor it out and tell me what's left. Okay, so finding the GCF still works the same. That's what's in this bottom box. Same thing we just did. But once we find that GCF, which we have identified here as 3, okay, 3x actually, we now have to divide each term by that GCF. So this portion right here is the GCF. So we are dividing by the GCF. So 9 divided by 3 gives me 3, and x to the 4th, take away one of them, I have 3 left. 15 divided by 3 is 5. X squared, take 1 away, I have just one of those left. 18 divided by 3 is 6. X, take it away, and there's nothing left here. So what we are left with is the factored form when we divide out the GCF, okay, with the GCF removed. So the final factored form would look like your GCF times whatever was left over. Okay, so you can't just throw that GCF away. Okay, it's still there in your final answer, it's just put out into the front. So this front is the GCF, and the back end is that portion that's left over after you pull the GCF out. Okay, so let's try a few of these. We have 5x plus 25, so I need to find the GCF. Okay, at this point, I know that 5 will go into 5 and 25, so I know I have a 5 here, and there's only one term that has an x, so I do not get an x or a variable. So factored form, okay, is I take the 5, and now I'm going to divide everything by this GCF. So when I take and divide the 5 away, I'm left with an x plus, and 25 divided by 5 is 5. So that is our final factored form, okay, which we're just going to call factored. Okay, over here with B, once again, I have to find that GCF. Well, I have 9 and 15. I know that 15 divided by 9 is not a whole number. 9's made up of 3's. So does 3 go evenly into 9 and 15? And it does. Okay, so that's a 3. And then they each have 1x. They both don't have 2. This last one doesn't have 2. It only has 1. So my GCF here is 3x. Okay, so I'm going to divide everything by that GCF. So my factored form is my GCF times whatever's left over. So 9 divided by 3 is 3. X squared, take away 1 is just x, minus 15 divided by 3 is 5. X, take it away, nothing left. So 3x times the quantity, 3x minus 5. Okay. All right, so part C, once again, finding that GCF. So the number portion, we have a 2 and a 16. 16 is divisible by 2. So therefore, my number portion is a 2 because that's the largest I have here. And then on the variables, I have an x to the 4th and an x cubed. So the most I can take away from each one would be an x cubed. So we're now going to divide everything by that GCF. So my factored form is the 2x cubed multiplied by, Okay, what's left? Well, 2 divided by 2 is 1, but we don't write a 1. X to the 4th divided by x cubed, I take 3 away, I'm left with one of those x's. Minus 16 divided by 2 is 8. X cubed, take away x cubed, there's nothing left there. So our final factored form here is x cubed times that quantity of x minus 8. All right, so down for part D. All right, now we've got numbers, x's and y's. Okay, so since I'm looking for 4, look for, that's the lowest number. Are they all divisible by 4? 20 divided by 4, that's even. 12 divided by 4 works. So that's a 4. Okay, the x's, I have x squared, x, and x. So the most I could take is one of the x's. I have a y cubed, a y squared, and a y. So the most I could take is 1y. Okay, now we're going to divide all of that by each term. So my factored form is 4xy times, okay, so 4 divided by 4 is 1, we don't write 1. X squared divided by x, I have 1x left over. Y cubed divided by a y, so I take 1 away, I have 2 y's. Plus, I'm going to do the same thing here, 20 divided by 4 is 5. The x over the x goes away. Y squared, take away a y, leaves me with 1y. 12 divided by 4 is 3. The x's go away, the 1y's go away, and so that is my final factored form, the GCF of 4xy times the remainder was xy squared plus 5y plus 3. So remember, when you're finding that GCF, you can use a table if you need to find your factors, okay? Always remember you have to be able to take it evenly from every term, okay? We don't write a 1, and when you write your final factored form, you put your GCF and then multiplied by the remainder after you divide out.